Titrations are a type of quantitative analysis known as volumetric analysis. This is where we use the solution of known concentration to determine the concentration of another solution. The most important concept in titrations is molarity. To demonstrate this, I'm going to determine the molarity of sugar in my cup of tea.
Firstly, weigh out the sugar. I take 1 sugar in my tea. Then measure the volume of tea with a graduated cylinder. Now just follow this slide to work out the molarity of sugar in your cup of tea. Indicators work based on the principle of pH. They appear as one colour in basic solutions and a different colour in acidic. This is why they're used to determine the endpoint of titrations, as neutralisation occurs within the moment at which the colour changes. pH is a measure of the acidity or basicity of a solution. It is illustrated on a pH scale that reads from 1 to 14, with 1 being the most acidic and 14 being the most basic. A pH of 7 represents a neutral solution. There are different methods of determining a solution's pH. The electronic meter shown here is the one you will use in the lab. The glass electrode at the end is very fragile and must be fully immersed in the solution to give an accurate reading. After each use, please wash the electrode with distilled water and make sure the lid contains distilled water, as this prevents the electrode from drying out. The conical flask is the reaction vessel for titrations. Volumetric flasks are used to prepare solutions of accurate concentration. Pipettes measure small amounts accurately. Burettes deliver known values of liquid via a tap. Primary standards are extremely pure and stable compounds. They are very important in analytical chemistry, and so it is vital that they are of precise concentration. When preparing a primary standard, you must weigh and record the exact mass of the compound. It is then transferred to clean, dry glassware, and only distilled or deionized water can be used to make up the volume. Volumetric flasks are designed for preparing accurate volumes. You must ensure the bottom of the meniscus is lying on the calibration mark. As you've seen already, the pipette is used for aliquoting small accurate amounts. Before using the pipette, you must rinse it with distilled water and again with a sample of the chemical you are using. Use a pipette filler to draw the chemical into the pipette and do not exceed the calibration mark. Empty the pipette via gravity. Note: touch the tip of the pipette off the side of the conical flask to ensure it is completely empty. The burette contains a tap for allowing liquid to flow into the conical flask. Again, before using, make sure to rinse well with distilled water and with the chemical that you are about to use. When filling the burette, make sure the tap is closed and fill it above the calibration mark using a funnel. Remove the funnel and fill the tap, bringing the meniscus down so the bottom is lying on the calibration mark. Placing a sheet of white paper behind the burette makes the meniscus more clear to see. Now we are ready to carry out our titration. The conical flask contains a pipetted volume of 1 chemical and a couple of drops of indicator. First, a rough titer is determined by allowing liquid to flow quickly from the burette until colour change is noted. This is an estimate of the volume of this compound needed to neutralise the compound in the conical flask. Repeat the experiment again, but vary the flow from the burette so you stop the titration at the moment the colour change occurs. You should repeat the experiment until you have at least 3 readings that agree within 0.1 milliliter of each other. Here are a couple of slides demonstrating the calculations that you need to be able to do in relation to volumetric analysis and titrations. We hope this video has improved your understanding of quantitative analysis. Why not check out our next video on qualitative analysis and ions?